Alright, friction. We're going to start with question number 1. Which vector diagram best represents a car slowing down as it travels to the right on a horizontal surface? The answer that you should have chosen is number 1. So we know that we have the motion is moving to the right, which means that it has a greater force pushing to the right. But if it is slowing down, that means you also have the frictional force that's going to be smaller than the direction that it's moving, because that net force is going to be greater in that direction. So your answer should be 1. Alright, question number 2 is student, and the wax skis she is wearing have a combined weight of 850 newtons. The skier travels down a snow-covered hill and then glides to the east across a snow-covered horizontal surface. Determine the magnitude of the normal force exerted by the snow on the skis as the glider glides across the horizontal surface. So if you have a person that is gliding across the surface, normal, remember, if let's say this dot represents the center of mass for our person, the normal is the line that is perpendicular to that person. So this is my force of normal. Which means that if this person is 850 newtons, that normal force is also 850 newtons in that y direction. So your answer to number 2 is 850 newtons. Question number 3 is a little tricky because you have to know the coefficient of sliding friction between the wax skis and the snow, which is not given here, and I guess they just thought that you should know it. But first of all, when I'm looking at the magnitude of force of friction acting on the skis, that means I'm looking for force of friction. If I'm looking for force of friction, I'm using the coefficient of friction as my equation. So that's where mu equals the normal force, which is, I'm sorry, not the normal force, the frictional force, or the pulling force, divided by the normal force. So pulling or pushing divided by whatever the weight of that object is in newtons. And then mu is just the number. If you have a small number, that means you have a little bit of friction. If you have a large number, that means you have a lot of friction. In this case, because it was snow covered, you're really using a very small number, and in this case it happens to be 0.05. If you use something that was less than 1, it should still be okay as well, but it's just a whole number, 0.05. Force of friction is what we're looking for, divided by the normal, which is 850. And so that should give you a frictional force of 42.5. And that's newtons. So you don't have this equation. Let me rewrite this again. So you have mu is equal to force of friction divided by the normal force. And this equation is not on your reference sheet, and so you need to make sure that you add that onto it. Okay. Next one we're going to do is question number 16. Question number 16, you probably recognize. We've done a lot of these. 16 says that a child pulls a wagon at a constant velocity along a level sidewalk. The child does this by applying a 22 Newton force to the wagon handle, which is inclined at a 35 degree to the sidewalk as shown. What is the magnitude force of friction on the wagon? So we're looking at the force of friction that is on the wagon. So that means we're looking for this force of friction in the x direction. So if we're looking for the x direction, it's almost exactly like what we've done before, dealing with the projectiles, right? So you have that x surface. So for 16, you're still kind of doing that. Instead of the initial velocity of x, you're doing the friction of x. So that's going to equal the actual force of what you have. So in this case, it says that the child does this by applying a 22 Newton force. So whatever that force is, that's the initial amount and magnitude that we have. And then because it's in the x direction, we're doing cosine, and that's going to be the 35 from the horizontal. So very similar to the projectiles that you've done before. So that means that we have our F and the X in the horizontal direction is 18 newtons. You should also know that whatever the force of friction is, which is equal to the force that's being applied, right? And that's based off of Newton's third law. Okay, next we're going to do question number 22. The diagram for 22 shows the 4 kilogram object decelerating at 10 meters per second squared on a rough horizontal surface. What is the magnitude of the frictional force acting on the object? So if we're looking for the magnitude of frictional force, we have acceleration and the forces that are being applied. You're using the same application that you would use for the second law. The only thing is you got to make sure that you have the net force, which we've done before, equals the mass times acceleration. So we know that we can find force this way, that is being applied. So force equals your mass, which is given to you as 4 kilograms, times the acceleration, which is 10 meters per second squared. So that means that your force is 40 newtons. Now, that's the force that we have that's acting on that object. So that means the frictional force in this case that we have, which is your applied force, equals your applied force minus whatever the net force is. So we want to make sure that we know the magnitude of the frictional force. So we know that what is applied has to be the same as whatever the net, which is the original that you have. And that's again based on third law. Whatever this minus this equals the total that's in the opposite direction. So whatever your applied force is, which is given to us as applied force is given to us as 50 newtons. And the net force is what we calculated, and that's the basic second law, which was 40 newtons. That means the force of friction that's being applied, which is the leftover, is the 10 newtons. Okay. Alright, next we're going to do question number 38. Question number 38, the diagram below shows a block sliding down a plane inclined at theta with the horizontal. As angle theta is increased, the coefficient of kinetic friction between the bottom surface of the block and the surface of the incline will... Now, you have to remember what friction is. Friction is the coefficient between two surfaces, so two surfaces rubbing together. We never change the surface of the block, and we never change the actual surface of the ramp, which means that these aren't going to change at all. It doesn't matter about, it's not asking about static friction. It's asking about the friction between these two materials, and the materials never change, which means you're always going to maintain the same coefficient. So that should be number 3. That should be 3 as your answer choice. Alright, next one we're going to do is question number 40. Question 40 has an 80 kilogram skier slides on a wax skis along a horizontal surface of snow at a constant velocity while pushing with the poles. What is the horizontal component of the force pushing forward? So we have to make sure that we know what the horizontal component is. So this is very similar to the very first question we do, but horizontal component means the force of friction. So that's our F of F. And we're still using the same equation we did before, which was that we have a coefficient, we know the force of friction, and we know what the normal is. So the first thing is we need to know the normal, which again is going to be 80 kilograms. So if I'm given kilograms, we're looking for the weight, which is 80 times whatever gravity is, which is your 9.8. And that is your normal. whatever the weight of something is. And then we talked about what the coefficient of wax and ski on snow is, and that's going to be 0.05. So the last thing that we have to figure out is what is the force of friction. And again, that means 0.05, we're going to multiply by your 80 times your 9.8, and your force of friction is going to be 39.2 newtons, which the closest to this answer is going to be 40 newtons. Sorry, and this is question number 40. So make sure that you know how to find weight. I think this might be on your reference sheet. I don't know, I don't have it with me. But check to make sure that this is. So weight equals mass times gravity. That's going to be your newtons. And that's how you get your newtons based on your weight. And your weight's always going to be in kilograms, and your gravity is in meters per second squared.